Welcome students. You are welcome to fourth part of chapter 1 in unit 3 higher order linear differential equations. In the third part of chapter 1 we have learnt about to find solutions of homogeneous linear differential equations of order n with the constant coefficients for the case when all the roots of auxiliary equation are real and distinct. To continue with the same chapter, we move to learn about find solutions of homogeneous linear differential equations of order n with the constant coefficients for second case. That is, all the roots of auxiliary equation are real but some are repeating. To solve homogeneous linear differential equations of order n with constant coefficients, one first solves the auxiliary equation to determine roots. Based on the nature of roots, we can find general solution for f of dy is equals to 0. Here, f of dy is equals to 0 is the symbolic form of homogeneous linear differential equations of order n with constant coefficients. Now let's see case 2, which arises while solving the auxiliary equation. In case 2, there are two types of observations. First one, if the auxiliary equation f of m is equals to 0 has a real root m is equals to a which repeats n times. That is, all the roots of auxiliary equation are equal to a. Then the general solution of the given differential equation f of dy is equals to 0 is y is equals to c1 plus c2 times x plus c3 times x square plus so on plus cn times x power n minus 1 of e power ax. Now, second observation, if the auxiliary equation f of m is equals to 0 has k real roots each equal to m1 and the remaining n minus k real roots all are distinct. It means up to k real roots all are equal to m1 and the remaining n minus k real roots which are mk plus 1, mk plus 2, so on mn all are distinct. Then the general solution of the given differential equation f of dy is equals to 0 is y is equals to c1 plus c2 times x plus c3 times x square plus so on plus ck times x power k minus 1 of e power m1x plus ck plus 1 times e power mk plus 1 x plus so on plus cn times e power mnx. Now let's see some example problems for case 2. First example, solve 16 times d square y by dx square plus 24 times dy by dx plus 9 times y is equals to 0. Now find the general solution of the given differential equation in example 1. To do this, first write the given differential equation. Next write the symbolic form of the given differential equation, which is 16 times d square plus 24 times d plus 9 of y is equals to 0. Thus we get f of d is equals to 16 times d square plus 24 times d plus 9. Now here in f of d, replace d with m. So we get the auxiliary equation like this. F of m is equals to 16 times m square plus 24 times m plus 9 is equals to 0. Now find the roots for auxiliary equation f of m is equals to 0. Here the auxiliary equation is a quadratic equation f of m is equals to 16 times m square plus 24 times m plus 9 is equals to 0. So we find the roots using quadratic formula. M is equals to minus b plus or minus root over b square minus 4ac upon 2a, where a is the coefficient of m square, b is the coefficient of m, and c is the constant in the quadratic equation. So here we have a is equals to 16, which is coefficient of m square, b is equals to 24, which is coefficient of m, and c is equals to 9, which is constant in the quadratic equation. Now substitute A is equals to 16, B is equals to 24 and C is equals to 9. In quadratic formula, M is equals to minus B plus or minus root over B square minus 4AC upon 2A. Thus we have M is equals to minus 24 plus or minus root over 24 square minus 4 into 16 into 9 upon 2 into 16. So we have two values for M, that is M is equals to minus 24 plus root over 24 square minus 4 into 16 into 9 upon 2 into 16, and another one M is equals to minus 24 minus root over 24 square minus 4 into 16 into 9 upon 2 into 16. Here the square root term root over 24 square minus 4 into 16 into 9 gives the value 0. Therefore we get M is equals to minus 24 plus 0 by 32, and other one M is equals to minus 24 minus 0 by 32. Therefore, we have two values for M which are equal, that is minus 24 by 32. Therefore, we have M is equals to minus 3 by 4, which is obtained by cancelling out 24 and 32 with the common factor 8. Thus, M is equals to minus 3 by 4 and again minus 3 by 4 are the roots of the auxiliary equation, which are repeated roots. Here all the roots of auxiliary equation are equal and it has two repeated roots. So we can take two arbitrary constants C1 and C2 and write the general solution of the given differential equation like this: y is equals to C1 plus C2 times x of e power minus 3 by 4 into x. Therefore, y is equals to C1 plus C2 times x of e power minus 3 by 4 into x is the general solution of the given differential equation. Now let's see one more example for case 2. Second example, solve d cube y by dx cube minus 3 times dy by dx plus 2 times y is equals to 0. Now find the general solution of the given differential equation in example 2. To do this, first write the given differential equation. Next write the symbolic form of the given differential equation, which is d cube minus 3 times d plus 2 of y is equals to 0. Therefore, we get f of d is equals to d cube minus 3 times d plus 2. Here in f of d, replace d with m. Thus, we get the auxiliary equation like this: f of m is equals to m cube minus 3 times m plus 2 is equals to 0. Now, find the roots of the auxiliary equation. F of m is equals to 0. Here the auxiliary equation is f of m is equals to m cube minus 3 times m plus 2 is equals to 0. As I explained in the earlier videos, follow the procedure to factorize the polynomial m cube plus 0 times m square minus 3 times m plus 2 by synthetic division and factorization methods to get factors for the polynomial. So we get m minus 1, again m minus 1 and m minus 2 are the factors of the polynomial m cube minus 3 times m plus 2. Therefore, the polynomial m cube minus 3 times m plus 2 has factorization m minus 1 into m minus 1 into m plus 2. Now we have m cube minus 3 times m plus 2 is equals to m minus 1 into m minus 1 into m plus 2. So, the auxiliary equation f of m is equals to m cube minus 3 times m plus 2 is equals to 0 can be written as m minus 1 into m minus 1 into m plus 2 is equals to 0. Now, from this equation, we get m minus 1 is equals to 0. Again, m minus 1 is equals to 0 and m plus 2 is equals to 0. Now from these equations we get the values of m like this, that is m is equals to 1, again m is equals to 1 and m is equals to minus 2. Therefore m is equals to 1, 1, minus 2 are the roots of the auxiliary equation which have repeated roots, in which 1 is the repeated root. Using these roots, we write general solution for the given differential equation like this: y is equals to c1 plus c2 times x of e power x plus c3 times e power minus 2x. Therefore, y is equals to c1 plus c2 times x of e power x plus c3 times e power minus 2x is the general solution of the given differential equation. Now some practice problems are given related to case 2, that is, when all the roots of auxiliary equation are real and some are repeating, to learners for practice. So learners, try to solve these practice problems. In the next video, let's see how to find general solution of homogeneous linear differential equation of order n with the constant coefficients for the case when the auxiliary equation has imaginary roots. Now let's see what we have learnt. We learned to find the solutions of homogeneous linear differential equations of order n with the constant coefficients when all the roots of auxiliary equation for given differential equation are real but some are repeating.